Okay, Mr. C forgot to hit the record button for today's class, or it was a couple buttons I forgot to press. It recorded, but it didn't record any of the slide transition, so I'm doing this again at night. So this was a Friday, so on Friday I basically collect homework. I ask if there's any questions. If you guys have any specific questions on section 4.1, just go ahead and send me those questions and I'll get back with you. We're going to go on to today's lesson, which is on 4.2. We're going to have a quiz next week on Wednesday. We'll talk more about it on Monday and Tuesday. So here's your homework tonight. Okay. Today's class is on equivalent fractions, and most of you have done this before, so this should be a quick review. We're going to do three things. We're going to make equivalent fractions, we're going to reduce fractions, and we're going to change things from proper to improper to mixed numbers. And like I said, I would be surprised if you've never been taught this before. But if this is your first time, the pace that I teach this will be rather quick. Make sure you ask for extra help on this if it's something you've never done before. So here we go. Yeah, it says new idea. It's not really a new idea, but think about this. If I took the number 8, well, it's the number 8, but you can also write 8 in different forms, and by that I mean you can use some operation symbols, and we can rewrite 8 as 16 divided by 2. Those are equivalent to each other. 16 divided by 2 is the same as 8, and we could play this trick forever. For instance, 24 divided by 3 is also the number 8, and it's an equivalent representation of the number 8. Well, so what? Well, the so what about that is that we're going to remember that fractions themselves can be written in, well, they can be written in a couple different ways. And most of you are looking at this and seeing 16 divided by 2 and telling me that, well, that's not a fraction. Well, remember, the fraction bar is the division symbol. So technically, these two representations of the number 8 are exactly the same. They're equivalent to each other. So 16 divided by 2, we did this last night, can also be written as 16 over 2. So all the other representations of 8, which is 16 divided by 2, written as fractions, for instance, 8 divided by 1, is equivalent to 16 over 2. And so is 24 divided by 3. All three of these are equivalent. So we have a name for that, and these are called equivalent fractions. So write this down in your notes. Equivalent fractions, those are fractions that represent the same number. And the example I gave is 8 over 1, it's 8. Well, so is 16 over 2 is 8, and so is 24 over 3. All three of those represent the value of 8, and they're all fractions, therefore we call them equivalent fractions. All right, today we're going to do three basic games, and that is we're going to make equivalent fractions, we're going to reduce fractions, and we're going to mess around with the types of fractions. There's three basic types of fractions. So that's what's on schedule for today. All right, we'll do them one at a time. Quick note from last class. So last class we talked about multiplying fractions, and we stated that to multiply two fractions, you multiply numerators with numerators, denominators with denominators. In other words, we multiply straight across. 1 times 3, I'm multiplying the numerators here. 1 times 3 is 3. 4 times 5 is 20. We get 3 over 20. Okay? Well, consider the same process here, but instead, right, instead of multiplying by a weirder fraction, I'm going to choose this fraction, 1 over 1. Well, let's think about this. 1 over 1 means 1 divided by 1. 1 divided by 1 is 1. And what's 1 times anything? Well, any number times 1 is itself. So 1/4 times 1 is a quarter. I haven't really changed anything. We're going to use this specific, it's not a trick, that we're going to use this specific idea here to make an equivalent fraction. So I'll take any fraction, 1/4 again, but this time instead of multiplying by 1 over 1, I'm going to pick a positive integer. I know that says pick any integer, but it's got to be a positive integer. Pick a positive integer, for instance 3, write it as a fraction, 3 over 3. I should say write 3 over 3, not write 3 as a fraction. 3 divided by 3, well, that's just 1, right? So that's the same as multiplying a fraction times 1, 3 over 3. That's 3 divided by 3 is 1. Well, that's the same thing as multiplying a quarter times 1. Now, granted, when we actually do that multiplication of a quarter times 3 over 3, we don't get 1 over 1 or even 1/4. We get, let's see, multiply tops with tops, bottoms with bottoms. We get 3 over 12. Well, 3 over 12 does not visually look like 1 over 4. But since 3 over 3 is the number 1, then we can claim that 3/12 is the same as 1/4. They are equivalent. So this is the process of making an equivalent fraction. You take any fraction, to include negative fraction, you pick any positive integer, right? Let's say 4. You write 4 over 4 and you multiply straight across. That will make you an equivalent fraction, a fraction that represents the same number as the original fraction. So negative 2/5, we multiply straight across. 4 times 2 is 8, 5 times 4 is 20. A negative times a positive is a negative. So we get negative 8/20. So we are going to claim that negative 2/5 is the same as negative 8/20. And that's what we're going to do today. That's the first game. We're going to make an equivalent fraction. So let's do one. So let's see. We take 1/5. We multiply by any positive integer. I'm just going to choose 3 over 3, right? And 3 over 3 is basically the number 1 in disguise. 3 divided by 3 is 1. And just multiply straight across. 1 times 3 is 3. 5 times 3 is 15. So we're going to say that 1/5 and 3/15 are equivalent. We've made one. Now, when you're doing this tonight for homework, you can choose any number you want. A lot of students like to choose 2 because it's easy. Now, you don't want to choose 1 because even though you make a fraction, it's the same fraction. So choose, like, let's say, any positive integer 2 and above. Some people like to multiply by 10 because that's easy as well, too. All right, so let's see. Negative 2/7, so I'm going to multiply once again by 3 over 3. That's just 1 in disguise. Multiply straight across. A negative times a positive is a negative. 2 times 3 is 6. 7 times 3 is 21. So negative 6 over 21. What do you think? You got this? Okay, here's 2 more. Go ahead and pause the video and give these a shot. And then when you got an answer, one quick note here. If you don't choose the number that I choose, you're going to get a different equivalent fraction. But for tonight, for homework, they're going to ask you to make an equivalent fraction. You're allowed to pick any number you want. I'll just give you a hint. I'm going to pick 3 over 3. Okay, now remember 3 over 3 isn't the only answer. It's one of an infinite number of answers. But I'll choose 3 over 3, multiply straight across. We get 18 over 33. That is equivalent to 6 over 11. All right, negative 1/2 if I multiply by 3 over 3. There's nothing special about 3 over 3. Let's see, 1 times 3, 2 times 3, that would be negative 3 over 6. That is equivalent to negative 1/2. Got it? All right. It's not really a but there's a different way of doing this, right? Of making an equivalent fraction. Well, think about this. If I start with really large numbers, 20 over 40, right, as a fraction, technically that's a small number, but the numbers appear to be large. The numerator is 20, the denominator is 40. Well, we can make an equivalent fraction by multiplying by 1. We can also make an equivalent fraction by dividing by 1. 1 divided by 1 is 1. Well, what's 20 over 40 divided by 1? Well, that's the same thing, 20 over 40. Well, we're just going to change it from 1 over 1 to a different number over itself, and that's still the number 1. So let me give you an example. If instead we divide, now it's specific, this one's really specific. When you multiply, you may multiply by any number, positive integer that you wish. When you divide, you must choose a common factor. That's a number that goes into both 20 and 40. So let's see, what goes into 20, 40? My options would be what? 2. What else goes into 20 and 40? 4, 5, 10, and 20. I think those are our options. 2. You could also say 1, but 1 doesn't really change anything. I'm going to choose 2. So we're going to divide top and bottom by 2. Right? Let's see, 20 divided by 2 is 10. 40 divided by 2 is 20. We get 10/20. Okay, and so we're going to claim that 20 over 40 is equivalent to 10 over 20. See how that's done? The only key here is when division is that you must choose a number that goes into both the numerator and the denominator. You can't just choose 6, for instance, or 8, for instance. Let's see, 8 goes into 40, but it doesn't go into 20. So the number that you choose, if you choose to do this by division, tonight for homework they'll make you do a few by division, must be a number that goes into both the numerator and denominator. Make sense? Okay, let me show you another one. Negative 5/25. If we want to do this by multiplication, we multiply by any number. But if we want to do this by division, we got to come up with a number that goes into both 5 and 25. Well, that one's a pretty easy one. What's that number? Yeah, that's the number 5. So let's see. 5 divided by 5 is 1. 25 divided by 5 is 5. And a negative divided by a positive is a negative. So we get negative 1/5. Make sense? So let's see. Negative 1/5 is the same as negative 5/25. Those are equivalent. All right. Here's 2 to do. We can do these together. Let's see, 12 and 16. So what are my options? Let's see, 2 goes into both. No, not 3. Oh, 4 goes into both. Not 5, not 6. Yeah, I think that's it, just 4. 2 and 4 were my two numbers. So let's divide by the big number, 4. Okay? So let's see, 12 divided by 4 is 3. 16 divided by 4 is 4. So we get 3/4. If this is going a bit too quick to you, remember you can always pause, rewind, and play it again. All right, the bottom one. Let's see, 24 and 32. Let's see, 2 goes into it. Does 4? Yeah, 4 goes into it. 6 goes into 24, but not 32, so not 6. 8, yeah, 8 would go into it. Anything else? 12, 10, no, it looks like that's it. Just 2 and 8. 2 and 8. 2 and, I'm sorry, 2, 4 and 8. 2, 4 and 8. So whatever floats your boat, I'll pick the biggest one, 8 there. Let's divide top and bottom by 8. 24 divided by 8 is 3. 32 divided by 8 is 4. And a negative divided by a positive is a negative. We get negative 3/4. Cool? All right, for homework, you're going to get a problem that looks like this. Now check it out. You see what it has there? It's got 2 fractions, and one number is missing out of one of the fractions. Here's how this game is played. You're going to take a look at the numbers, and you're going to see as we go from left to right, from number to question mark, right, whether the numbers are getting bigger or smaller, right? Look at the denominators here. I'm going from a 3 to a 6. Well, the only way to get from a 3 to a 6 is through multiplication, right? Your choices are either multiplication or division. So we're going to multiply by some number. Let's see, how do we get from 3 to a 6? Looks like we multiplied by 2. It's just a coincidence that the numerator is there is 2. So let's see, if I were to write this with a little bit of space here and put in the thing that's missing, it looks like if we go from left to right, we're multiplying the bottom number by 2. That's how you get to 6. Well, if you multiply the bottom number by 2, you got to multiply the top number by 2. Because remember, 2 divided by 2 is 1. We're not changing the value. We're just changing the visual parts of the fraction. In other words, we're changing the numbers. But the value stays the same. 2 times 2 is 4. So we're going to say that 2/3 is the same as 4/6. Now look at the start with the question mark. Look at the finish and see if you can wrap your head around what's going on. See if you can see the pattern. As we go from left to right, it looks like we're multiplying both numbers, the top number and the bottom number, by 2. But you're going to be presented with something with a question mark. So once again, you're going from number to question mark. Sometimes you're going to be going from left to right. Sometimes you're going to be going from right to left. So this one I'm going from number to question mark. I'm going left to right. And if you look at the bottom numbers there, the denominators, 32 and 16, well, we don't get to 32 to 16 by multiplication. We get there by division. So it looks like we're dividing 32 by what to get to 16? It'd be dividing by 2. So we're going to divide the top and bottom by 2. We're going left to right. Well, 32 divided by 2 is 16, and 14 divided by 2 would be 7. So the answer would be negative 7/16. I believe the book just wants you to write down for homework tonight what is the value for the question mark. So in that case, the answer would be 7. If we're looking at just what should I place over the question mark, that's the number 7. Does that make sense? Okay, let's see a couple more. Now this time I've given you the space already so you can kind of see what's going on. Well, let's see. We're going from number to question mark. So the first one we're going from left to right. And we look at the two numbers in the top, 7 to 35. Through multiplication or division, yeah, from that's got to be multiplication to get to 7 to 35. That'd be multiplied by 5, right? So all we got to do is finish that multiplication off. 25 times 5. Those are big numbers, but you can do this. 25 times 5 is 125. There we go. So once again, if they're asking for what the question mark is, the question mark is 125. The equivalent fraction is negative 35 over 125. Okay, the last one here. Let's see, how do I go from 18 to 2? From 18 to 2, I think that's divide by 9. Yeah, that's right. 18 divided by 9 is 2, and 27 divided by 9 is 3. So 2/3. Got it? Okay, does that make sense? Good. I got 2 more. Go ahead and try these. I apologize. It looks like I put the question mark each time on the right side. Just be ready. The question mark could be on the left side. So you go from number to question mark, number to question mark. All right, how'd you do? Let's see. On the first one, we're going from a 2 to a 6. That's multiplied by 3. So if we multiply the top and the bottom by 3, we would get, what, 6 over 27. On the bottom one, right? It looks like we're going from a negative 20 to a negative 4. That would be divide by 5. And if we do the top, 10 divided by 5 is 2. So what, 2 over negative 4. Make sense? Okay, if not, play the video, and if it still doesn't make sense, send me either a message on Teams or an email. I'd love to help you out. All right, first game is done. Let's reduce some fractions. Remember doing this? You've probably done this for a couple years, reduce fractions. Well, the reason why we start off with equivalent fractions is because equivalent fraction would be the one that you start with, and reducing would be equivalent fraction would be the answers that we've been given, and reducing the fraction would be the number that we start with in the previous game that we played. So reducing fractions, the basic rule is this. You need a number that goes into both 10 and 20 that's not 1. I mean, 1 will go into everything. Also, we're not going to divide by 0, right? So let's see. What number goes into 10 and 20? Well, clearly 2 does, right? So we divide top and bottom by 2. Truly, we are making an equivalent fraction, but you always have to ask yourself, well, you're going to continue this until there's no other factors of the numerator and the denominator except for 1. Is there any other number that goes into 5 and 10? Sure, 5 goes into both 5 and 10. So let's divide by 5. So let's see, 5 divided by 5 is 1. 10 divided by 5 is 2. We get a half. Okay? Well, there's an easier way of doing this, but sometimes it's not the easiest way because you may not realize that the largest number that goes into 10 and 20, I'll do the problem again, is 10, right? And now if you can realize you can figure out the largest number that goes into both numbers, well, then you can do this all in one step. Well, check it out. 10 divided by 10 is 1. 20 divided by 10 is 2. We did it all in one step. And it's not a coincidence that if you look at the top part there, we divided by 2 and then we divided by 5, that 2 times 5 is 10, right? So whether you do it in 2 steps or 3 steps or 1 step, as long as you get to the answer, you're good to go. Most students, I call it the 5-second rule. You think about the two numbers for no more than 5 or 6 seconds, and then you pick whatever number comes to your mind that goes into both, and you just make some progress. So a lot of times, if you can get the number slightly smaller, then you can come up with the factors really easy. I mean, kids might stare at 10 and 20 for a minute before they realize that 10 goes into both 10 and 20. Here's another example, 45, 75. This is another one of those. There's a big number that goes into both of those numbers, but maybe you don't realize it. But most students would be able to realize right from the start that you could divide both by 5. Both numbers end in a 5. So, I'm all for, let's just make some progress. So let's see. 45 divided by 5 is 9. 75 divided by 5 is 15. Okay? And let's see, anything else going to 9 and 15? This is a little bit harder. A lot of times you don't realize that 3 goes into both of those. So we could divide both of those by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So we get 3/5. So that took us 2 steps. However, once again, if you realize that 15 goes into both from the very start, you would have been done in 1 step. Okay? Does that make sense? Hopefully you've done this before. So let's do a couple together. Here we go. 21 and 35. Let's see, 21 and 35. 21, it's not 2. They're not even. 3 doesn't go into 35. It's not 5. 7 goes into both. So we could divide top and bottom by 7. 21 divided by 7 is 3. 35 divided by 7 is 5. So we get 3/5. Cool. All right, 56 and 72. Once again, big numbers. You can think about this for a while. You may have a guess of what goes into both of them, but clearly if they're both even, then 2 goes into both. You could at least get some progress done with a 2. Some of you might be able to figure out the larger number that goes into both, but we'll use 2. All right, so let's see. Half of 56 is 28. That's divided by 2, by the way. Take half. 72 divided by 2 is 36, and you don't drop that negative. That negative needs to go along with it. Let's see, 28 and 36. Well, they're still even, so let's divide by 2 again. Let's see, that would be what, 14, negative 14 over 18, and they're still even. Let's do it by 2 again. So negative what, 7 over 9, and I think that does it right there, right? Now notice if we would have divided by 8, that's 2 times 2 times 2 from the very start. Maybe you did realize that. Then we could have done that in 1 step. So what do you think? You got reduced to fractions? Good. Okay. All right, last thing. This is one that probably needs to go in your notes. Most people don't forget how to reduce a fraction, but a lot of students forget how to change fractional forms. So let's write down a few definitions first. There's 3 types of fractions. The first one is called a proper fraction. Here's an example of one. That is where both the numerator and the denominator are fully reduced, and the numerator, the top number, is smaller than the bottom of the denominator. That's called a proper fraction. The numerator is smaller than the denominator, and the fraction is fully reduced. Okay? The next one is called an improper fraction. Here's an example. It's kind of not necessarily the opposite, but it's one where the numerator is bigger or larger than the denominator. But once again, the fraction has to be fully reduced. So that's called an improper fraction. And the last one is called a mixed number. That's a mixture of an integer, positive or negative, right, and a fraction, for instance, 3 1/4. And it probably should say a mixture of an integer and a proper fraction. Okay, because you're not going to see a mixed number with an improper fraction. Okay, so the games we're going to play today are, well, we're going to basically switch from one form to the other. I'll give you an improper fraction. You're going to change it to a mixed number. I'll give you a mixed number. You're going to change it to a, wow, I can't spell very well there, fractions. Fractions is what it's supposed to say there. Okay? All right, so let me show you the procedure. Hopefully this is just recall that you've done this before. So here's an improper fraction. The numerator is bigger than the denominator, fully reduced. To change this into a mixed number, we start with the bottom number, the denominator. The denominator is 5. And here's the procedure. We say, how many times can 5 evenly go into 7, right? Well, that would be 1 time. Well, what would be the remainder? What would be left over? 5 goes into 7 once with 2 left over. 2 now becomes the numerator. 5 stays the denominator. So the remainder would go on top. The original denominator goes on bottom, and that integer out front is how many times the original denominator goes into the original numerator. Is this stimulating your memory? You remember doing this? Hopefully. If not, write this down in your notes. All right, another example. Improper to mixed number. Let's see, we got to divide 4 into 11. 4 into 11 goes 2 times. 4 times 2 is 8. That would leave 3 as the remainder. And the original denominator is 4, so 2 3/4. So remember, the top number is the remainder, and the bottom number is the original denominator. Is that confusing, or you got this? Okay. What happens if it's negative? Well, nothing happens. We just ignore the negative and tack the negative sign on at the end. We still think of 2 into 9. Let's see, 2 into 9, we go, what, 4 times with 1 left over? So 4 1/2, but the answer is going to be negative, so not 4, but -4, remainder 1, and 1/2. The original denominator was 2. So if you need to write this down, quick note, right? For negative improper fractions, you ignore the negative sign until the final answer. For instance, we just changed 9 over 2 into a mixed number, and we tack a negative onto it. Okay? Make sense? All right, so let's do a couple of these. All right, so the first one's negative. I'm going to ignore it and place it at the very end. So we know the answer will be negative. 5 goes into 29, what, 5 times? With how many left over? 5 times 5 is 25. Oh, 4 left over. So -5, that'd be how many times 5 goes into 29? -5, and there's 4 left over, so 4/5. Because remember, 4 would be the remainder. 5 is the original denominator. Second one, let's see, 9 into 38 goes 4 times. 9 times 4 is 36. Oh, 2 left over. And 2 ninths. Okay, the remainder was 2. 9 was the original denominator. All right, I think that's enough of that, right? Plus, we've done that before. All right, the last game is we're going to make a mixed number into an improper fraction. Taught a lot of different ways. I call this a circular method. You won't see that in the book, but we make a circle. We start with the denominator here. The denominator is 7. We're going to make a big circle here. And here's the procedure. We say denominator times the integer. So denominator times the big number, 2. So 7 times 2 is 14, plus 4 is 18, all over the original denominator. So we better write this. So let's see, the top number, how do you get the top number? That is the product of the numerator, right, and the integer, right, plus the original numerator, okay? Product plus the numerator. So the product of the 7 and the 2 plus the 4, all over the original denominator. And if you don't, if you're not unsure, or if you're unsure that you got the right answer, just make it into a mixed number again. Let's see, 7 goes into 18 two times with 4 left over, so yeah, 2 and 4 sevens. Make sense? All right, so I'm using a little shortcut writing there, product plus the numerator. All right, so let's see. The negative, we're going to ignore it. We're just going to make the final answer negative. We're going to ignore it to do the math. 7 times 5 is 35, plus 3 is 38, all over 7. So let's see, negative 38 over 7. Remember, the top number is the product plus the numerator. The product of 7 and the integer out front, negative 5. Except we're going to ignore the negative, right? Because technically, 7 times negative 5 is negative 35, plus 3 would be negative 32. That's why we're going to ignore the negative until we get to the final answer. And then remember, it always goes over the original denominator. So maybe make another note. For negative mixed numbers, you're going to ignore the negative sign until the final answer. Okay, so when you're changing that mixed number into an improper fraction, you don't do 7 times negative 5. You do 7 times 5 plus 3 all over 7, and then tack on that negative. Got it? Okay, 2 more and we're done. All right, let's make these into improper fractions. Let's see. 4 times 3 is 12, plus 1 is 13, so we get 13 over 4. Okay? Remember, that's the product plus the numerator. Bottom number is the original denominator. Second one, we're going to ignore that negative. 8 times 3 is 24, plus 7. 24 plus 7 is 31. 31 over 8. Then we're going to tack on the negative, right? So negative 31 over 8. How about it? Make sense? You got this? Remember, it's a video. You can always pause, rewind, play it back as many times as you need. And you can also send me a message in Teams, or you can send me an email. Any of those work if you need help. I've been tutoring a few people on Zoom as well, too. So if you need a Zoom tutoring session, don't hesitate to ask. All right. Well, it's Friday for us. We just did our 3 tricks for the day, and we are going away for the weekend. So have a great weekend. Do something fun, and I will catch you guys on Monday. Ciao.